Here we're going to look at rational numbers and irrational numbers. Now at year 8 level you don't need to know a lot about this. Most likely you'll just be given a list of numbers and asked to determine whether they're rational or irrational. But what does this actually mean? So let's look at what constitutes a rational number. Rational numbers can always be expressed as fractions. They can, therefore, always be expressed as whole numbers. If you think about any whole number, we can express that as a fraction, 3 out of 1 or 6 out of 2, and so on. As we've seen with fractions, they can also be expressed as terminating decimals or recurring decimals. So if we see a fraction or a terminating decimal or a recurring decimal, all of these are rational numbers. However, irrational numbers cannot be expressed as fractions. When they're expressed as decimals, the decimal expansion is infinite, which means it goes on forever. For practical purposes, it goes off the side of your calculator. And there is no recurrence pattern, so we can never pick off a pattern like this. A surd is a particular type of irrational number. So in other words, a surd is a number which cannot be expressed as a fraction. It is the square root of a number which is not a square number. So we know the square numbers 1, 4, 9, 16 and so on. So if we take the square root of one that isn't a square number, such as 8, then this would be a surd, and it's an irrational number. It can't be expressed as a fraction. But if we take the square root of 16, which we know is a square number, that is a whole number, and we know that a whole number is a type of rational number. It can also be the cube root of a number which is not a cube number. So if we think about the cube numbers 1, 8, 27, 64 and so on, the cube root of 9, since 9 is not a cube number, would be a surd, and so on. So it could be the fourth root of a number which is not a perfect fourth power, and so on. But I've never seen a question ever which isn't either a square root or a cube root. Now that's a lot of information in one go, but let's look in practical terms at what we actually need to do here. So for these numbers here, we're either going to write R for rational or I for irrational. If we look at this first one, that's a whole number. We've already determined that any whole number is rational. Here we have a terminating decimal. Any terminating decimal is rational. Now pi is one that you really need to know about. Pi is an irrational number. It's not a surd because it's not a square root or a cube root or any of that type of thing, but it is an irrational number. So make sure that you note that fact. Pi is an irrational number, and so would anything times it, like 2 pi or 7.2 pi. If you just multiply it by a rational number, it will still be irrational. So this one is irrational. This one here has recurrence. So if we have a recurring decimal, that's going to be rational. Now let's move to these ones. 7 is not a square number. Therefore, the square root of 7 is a surd, which is a type of irrational number. The square root of 49, however, with 49 being a square number, is 7. So this one is rational because it's a whole number. 12 is not a cube number, so the cube root of 12 is a surd, it's irrational. 27 is a cube number. The cube root of 27 is actually equal to 3, a whole number, so this one is rational. Now if you look at this one, you might not know what to do. But if you've got your calculator, just go 11 plus the square root of 17, which is a surd, which is probably a clue that this is going to be irrational, divided by 8. And if on the screen here we don't see any recurrence, and we can see that there isn't, at this level that's good enough to say that this one is irrational. There's only one more thing to discuss, and that is that we know that rational means that we can express the number as a fraction. So if you see a fraction, then that automatically is going to be a rational number.